Hello students, welcome. So I was teaching you all the method of mathematical induction. I am happy that I received many positive feedbacks regarding the previous video which I uploaded. So we will continue with this method, and today I'm gonna discuss with you all two three problems on the method of mathematical induction, and I think. Discussing problems, it will give you more insight into this method. In the last video I continued the method of mathematical induction with the LHS and RHS method, right? Proving the formula by LHS and RHS method. And today I shall teach you to prove it by simultaneous adding and also multiplication method. Okay, so I will teach you by that method. Actually, I talked to my mentor and he suggested that I must also teach you this method. So I shall continue the next problems with the simultaneous adding method. Okay, so let's begin. So here in the screen, so we are given equation. So it says that using the method of mathematical induction, so that the sum of the even natural numbers is equal to n into n plus 1, okay, where n is a natural number, okay, n belongs to natural number. So as per the method, we shall first we shall define this statement. So let's name it Sn. Let Sn be 2 plus 4 plus 6 plus dot 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 plus 2n equal to n into n plus 1, where n is a natural number, right? So we have defined this statement. So as per the method of mathematical induction, so first we will test the validity of this statement for the least natural number, which is 1. Okay, let's begin. So for n is equal to 1, okay, so S1, if we look at this side, LHS term, so for n is equal to 1, we'll consider first term 2, or you can just substitute the term 1 in n. Okay, so by doing this you will get 2 into 1 2, or you can also consider this term. So it is 2, then which is equal to in the right hand side we will put 1 here. Okay, so let's substitute 1. So or you can put the implied sign equal to 1 plus 1, which is 2. 1 into 2, 2. So 2 is equal to 2, which is a true statement, right? Which is true. So thus for n is equal to 1, the statement Sn is true. So Sn is true for n is equal to 1. So now we shall consider that this statement is true for n is equal to k, and considering that, we shall next prove that this statement is true for n is equal to k plus 1. So now we will consider that let this statement Sn be true for n is equal to k, where k belongs to natural number. So it is you must incorporate this statement that k belongs to natural number, because we are considering the numbers to be which we are dealing with the natural numbers, right? So you must write that k must belong to natural number, then only it is correct. Okay, so now we consider that the statement Sn is true for n is equal to k. Okay, so if this statement is true, then we can write that in place of n we can incorporate k. Okay, so 2 plus 4 plus 6 plus dot 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 plus k gives k into k plus 1, where k belongs to natural number. So considering this, we need to prove that this statement is true for n is equal to k plus 1. Okay, so if you look into this statement above, so we can just break this statement as this. Okay, 2 into 1, which is equal to 2, 2 into 2, which is equal to 4, 2 into 3, which is equal to 6, plus dot 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 plus 2 into k. So we are to prove that considering this statement Sn is true for n is equal to k, we are to prove that this statement Sn is true for n is equal to k plus 1. So what must we do so that this statement becomes Sk k plus 1. This is sk, right? This is sk, this is sk. So what we need to do, that this statement now becomes sk plus 1. So if we add to this part 2k plus 1, then this statement will become sk plus 1, right? So what we will do, that we will add 2 into k plus 1 on both sides, so that this statement becomes sk plus 1. Okay, so let's add as 2 into 1 plus 2 into 2 plus 2 into 3 plus dot 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 plus 2 into k. Okay, 2 into 10 k plus 1. If we add to this side LHS, then we need to also add to the right hand side, so that it cancels out. Okay, so that the equality remains same. So k into k plus 1 plus, so we have added it on the both sides. Okay, so I broke these statements for your better understanding, and now I will just write it simply. 2 into 1 is 2, 2 into 2 is 4, plus 2 into 3 is 6. Okay, 6 plus dot dot plus 2k plus 2k plus 1. Okay, and we see that k plus 1 is common in both the terms, so we can take out k plus 1 as common, and what we will be left out, k plus 2. Okay, so if you now notice that this statement has become sk plus 1. Okay, this statement has become sk plus 1, so we can replace it by sk plus 1. Okay, so we can replace it by sk plus 1. So if we replace it by sk plus 1, then if we look on the right hand side, we see that we can write this term as k plus 1 plus 1. This is nothing but k plus 2, right? We can write it as k plus 1 plus 1. And if I ask you to write that term as k plus 1, what you will do? You will do that 2. You will add 2 plus 4 plus 6 plus dot 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 plus 2 k plus 1, and on the right hand side, what you will do? In place of n, you will incorporate k plus 1, right? So if you incorporate in place of n k plus 1, then what you will get? Wait for a second. Then you will get in place of n, if you incorporate k plus 1, then it will become k plus 1 bracket k plus 1 plus 1, right? So this is what we will get, and yes, this statement is true, right? So this is true, this is true. So we have proved that the statement Sn is true for n is equal to k plus 1, and this was what we are to prove, right? So we can now conclude that we have earlier proved that this statement Sn, the sum of the even natural numbers, is equal to n into n plus 1. This was true for n is equal to 1, which is the least natural number, and we considering that this statement Sn to be true for n is equal to k, we proved that this statement is true for n is equal to k plus 1. So by the method of mathematical induction, so now we can conclude that this statement Sn is true for all natural numbers. Okay, this statement is true for all natural numbers. So now let's move on to the next question. Okay, in this statement, we are given that by the method of mathematical induction, we need to verify whether the statement is true. Okay, what is the statement? It is the sum of the cubes of the natural number, the sum of the cubes of the natural number, right? So the sum of the cubes of the natural number is equal to, it is given by the formula n into n plus 1 divided by 2 whole square. Okay, where n belongs to natural number. Okay, so as per the convention, we will first define this statement. Okay, so let Sn be 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube equal to n into n plus 1 divided by 2 whole square for n belongs to natural number. Okay, so at first we have defined this statement. So what is the next step then? We need to verify whether this statement is true for n is equal to 1, which is the least natural number. So for n is equal to 1, okay, for n is equal to 1, for n is equal to 1, what will be the statement? Then it is s1, right? S1. Then if we take s1, what will be the RHS? It is nothing but this. It is the first term, right? Or you can do that. You can incorporate 1 in this n term, and 1 cube will be 1, right? So it is 1 cube. Okay. And on the right hand side, what you will do? You have to incorporate 1 on the this formula. So incorporating 1, we will get, so it is implies 1 cube equal to 1 into 2 divided by 2 whole square, right? What is 1 cube? It is 1, and 2 cancels out, and we are left to 1 square. So 1 is equal to 1. Yes, 1 is equal to 1. It is a true statement, right? Which is true. And thus we can conclude that Sn, the given statement, is true for n is equal to 1. So what's the next step? We will now verify whether this statement Sn is true for n is equal to k plus 1. So we first consider that this statement to be true for n is equal to k, and then using that statement we will prove that this statement is true for n is equal to k plus 1. Okay. So now we will consider that this statement Sn is true for n is equal to k. Okay. So considering that this statement is true for n equal to k, so we need to now prove that this statement is true for n is equal to k plus 1. Okay. So we consider that as k, that is 1 cube plus 2 cube plus 3 cube plus dot 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 plus k cube is equal to k into k plus 1 divided by 2 whole square, where k belongs to natural number. So this you must not miss this term, because we are considering the natural numbers and we are dealing with natural numbers. So so you must write this. Okay, you are using the properties of natural numbers. So if you don't mention the statement that k belongs to natural number, then it is not correct. Okay, so you need to mention this. And as what we did, that in place of n we just incorporated k. Okay, so now again, like the previous question, so if we need to make this term, k, this is sk, right? If you need to make this term sk plus 1, so what you need to do? You need to just add one more term, that is k plus 1 cube, right? You need to add just the next term, which is, if I ask what is the next term to 3 cube, it is 4 cube, right? What is the next term to 4 cube? It will be 5 cube. Likewise, what is the next term to k cube? It is k plus 1 cube, right? K plus 1 cube. So you need to just incorporate the term k plus 1 cube, so that this statement, which is now sk, it becomes sk plus 1. Okay, so let's write 1 cube plus 2 cube plus 3 cube plus dot 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 plus k cube plus k plus 1 cube. So if you add this term k plus 1 cube, k plus 1, you must first write that adding k plus 1 cube on both sides. Okay, so we added k plus 1 cube on both sides, so that this statement becomes sk plus 1. So if you add this on the right hand side, you must also add on the if you add this term on the left hand side, so you must also add it on the right hand side, so that the equality is maintained. So k into k plus 1 divided by 2 whole square plus k plus 1 cube. Okay, so we are done with this. So this statement is nothing but you can replace it by sk plus 1. Okay, and this becomes if you just this is nothing but these are product terms, so you can just distribute the power. Okay, k plus 1 square, what is 2 square? It is 4, right? Plus k plus 1 cube. So now we will take the LCM, k plus 1 square by 4. Okay, so we need to take the LCM now, 4k plus 1 cube. Okay, if you notice that k plus 1 square is common in both the terms, right? K plus 1 cube is common in both the terms. So what we will do, you will take the k plus 1 square common. Okay, so k plus 1 square, taking k plus 1 square common. So what we are left out inside this bracket, You can also take 4 common, right? You can also take 4 common. So taking these terms common, what we are left out inside the bracket, it is k square. Okay, k square. Then here 4, and it was k cube, right? So we took k plus 1 square common. So what we are left out inside the bracket, k plus 1 only. Okay, so we are left out with this. So we will just simplify it, and we will get the result. Okay, k square. So it is 4k plus 4. Okay, k plus 1 by 2. You can do this. I have meant put it whole square. Okay, so if you look at this, it is, you can write this k square plus 2k plus 2. Oh, sorry, into 2. 2k, you can write k square plus 2k into 2. Okay, 2 into 2, it is 4, into k, it's 4k. Okay, 2k into 2, it is 4k, plus you can write this term 4 as 2 square. Okay, if you notice that this is nothing but a plus b whole square formula, a square plus 2ab plus b square. Okay, so it falls under the a plus b whole square formula. Just look at this. It is k square plus 2ab. Okay, a into b. So 2k into 2, it is 4k, right? 2 into k into 2 is 4k. So it is like 2a into b plus b square. Okay, so it is so we can write the whole square term now. Okay, so what we can write, it is here a is k and b is 2, right? So we can write k plus 2 whole square. Okay, now we can just we can take the square term common. Okay, so k plus 1 by 2 into k plus 2. Okay, we just took the power common. K plus 1 by 2, k plus 1 by 2 into k plus 2. We just took the power common. Okay, and if you notice that you can write this term, as what you can write? You can write it as k plus 1. Okay, and you can write the k plus 2 term as k plus 1 plus 1. Okay, you can write it as k plus 1 plus 1. And this was all that we need to obtain. Okay, if you notice that it was like n into n plus 1 divided by 2. And yes, as we assume that n is equal to k, we obtain that it is k plus 1, which is n, into k plus 1 plus 1, which is n plus 1 divided by 2. So considering n is equal to k plus 1, we need to prove that s k plus 1 was equal to this, and we obtained this, and thus this is true, right? So we can write this is true. So thus we can conclude that the term Sn, the statement Sn is true for k plus 1. So we can just now conclude that the statement Sn is true for n is equal to k plus 1. So earlier we verified that this statement Sn was true for n is equal to 1, which is the least natural number, and now we verified that this statement is also true for n is equal to k plus 1, considering that this statement was true for n is equal to k. So we obtained that this statement was true for n is equal to k plus 1, and thus we can now conclude that by the method of mathematical induction, the statement Sn is true for all natural numbers. Thank you. Hope this video was helpful to you, and we will continue our lecture in the following classes.